Okay, good day. We will report about the linked list data structure. Next, what is a linked list? A linked list is a linear data structure that includes a series of connected nodes. Here, each node stores the data and the address of the next node. For example, this. Yung sa head niya, yung head, yung start niya, parang next node niya ay data, tapos yung data hanapin yung kasunod, yung second data, and next naman ay data to null. Next slide. You have to start somewhere. So we give the address of the first node a special name called head. Also, the last node in the list, in the linked list, can be identified because it is the next portion points to null. Linked list can be a multiple types, singly, doubly, and circular list. May tatlong types ang linked list. Singly or singular, doubly, double sa, or circular or circular. Next. Ang example nung singular kanina, yung pinaka straight siya. Ito namang unang picture na ito yung doubly. Magsisimula siya sa head, sunod sa node A, tapos next B, C, D, tapos babalik ulit siya sa D, C, B, A. Tapos yung circular list naman, pag nagsimula siya head, hanggang node 1, node 2, node 3, node 4, tapos pagka last node, babalik ulit siya sa start sa head. Top, next. Isa pa yan, yung circular list. From head to last and back. Next. Okay, representation of a linked list. Let's see how each node of the linked list is represented. Each node consists of a data item, an address of a node. We wrap both the data item and the next node reference in a struct as struct node, it data, struct node next. Gato. Pag ma-representation ng linked list ay kailangan nandun yung data item and yung address of another node. Katulad dito sa example. Sa structure ng node ay nandun yung data tapos yung structure ng node kung ano yung next susunod sa data. Next slide.
Understanding the structure of a linked list node is the key to having a grasp of it. Each struct node has a data item and a pointer to another struct node. So to have a better understanding on linked lists, we will show some nodes. Next. The first line of code here is how you initialize nodes. So struct node head, node 1 equals to null, and node 2 equals to null, node 3 equals to null again. And after that, we allocate the memory of node 1, 2, and 3. After allocating the memory naman, we assign the data values of node 1 to data equals to 1, node 2 equals to data equals to 2, node 3 to data equals to 3. After that, we connect the nodes. Um, so node 1 to next is equals to 2, node 2 to next is equals to 3, and node 3 to next is equals to 9. And last step is we save the address of the first node in the head by declaring head is equals to 1. So next slide. Next slide. If you didn't understand any of the lines in the previous slide, all you need are measurements of pointers and structs. In just few steps, we have created a simple linked list with 3 nodes. So We have a simple structure here ng visual representation ng linked list. Pa, so yung head connected siya sa node 1, next to node 2, next to node 3, and to null. Next slide. So here we have an example of how you insert a linked list. So yung unang diagram dito, ito yung linked list, and after inserting a linked list, ganito yung magiging itsura niya. Yung nasa babang diagram. Yan lang. Next.
The power of a linked list comes from the ability to break the chain and rejoin it. For example, if you wanted to put an element 4 between 1 and 2, the steps would be 1. Create a new struct node and allocate memory to it. 2. Add its data value as 4. 3. Point its next pointer to the struct node containing 2 as the data value. 4. Change the next pointer of 1 to the node we just created. Doing something similar in an array would have required shifting the positions of all the subsequent elements. Create a new struct node and allocate memory to it. In Python, the linked list can be implemented using classes as shown in the codes below. Linked list utility. Lists are one of the most popular and efficient data structures with implementation in every programming language like C, C++, Python, Java, and C Sharp. Apart from that, linked lists are a great way to learn how pointers work. By practicing how to manipulate linked lists, you can prepare yourself to learn more advanced data structures like graphs and trees.
Okay, as you can see here, there is a code here, a sample code of a singly list, linked list. The first class is a class for node, and the second class is for linking nodes or lists. To create a node, you need to define the main function with two variables, the self and the item, or the head, self or head, and the item. So self, that item is item or the head, and next to head is none. So it means that there's nothing else, just an empty one. So it's like two containers. One is the head and the other one is the item. Next, for linked list class, it's the same as the class node. You define a main function, but the difference is that it only has one variable, which is self or the head, and it has no variable. So if name is equals to main, it is the main class. Uh, you call the linked list uh, class and then input it to a underscore list variable to assign items item values. You call the linked list and then call head using the methods in class linked list, and then you input node 1, same as second and third. So you have three items in which has also has three nodes. So to connect all the nodes, uh, first you call the linked list, then the head, and the next, then insert second. Now you call second the variable second, then call the next, and enter third. So once you print the linked list item in a loop, while linked list that head is not none, print linked list head item and in space. So here in the singly linked list, it only goes from the head and goes to null or an empty value. So if there is no more elements in the array or in the list, it will end the program. So this is a hard code of how a list works. Next slide, please. So here is a linked list complexity, which shows the time complexity and the space complexity. So if you search in a linked list, both either worst case or average case, it is in the order of n, which is linear. The time and the space consumed is the same, whether it increase or decrease. Uh, when you insert an item, it is also both uh, constant or order of one. So it does not matter. So the time and the space consumed doesn't change whether you insert or delete a certain item in a linked list. Next. So here is an list of linked list applications. First, dynamic memory allocation. So linked list is applied in dynamic memory allocation or a flexible allocation of data in the memory or RAM to avoid unnecessary waste of space. Linked list is applied. Next, implemented in stack and queue. So the stack and queue method in program, linked list is much more preferred compared to an ordinary array since uh, during deletion and insertion of a certain item, it does not change its complexity. So it is a constant complexity. Next, in undo functionality of software. So the same as insert and delete in stack and queue, in the undo functionality, uh, for example, you inserted an item and you want to undo the insert, so it's like removing the first or the value that you have inserted. So it does not change the time complexity and also the space complexity. So linked list is much more preferred compared to a ordinary array or list. Hash tables and graphs. So hash tables and graphs are much more complicated to a simple list or array of tables. Since it's in a matrix, excuse me, since hash tables and graphs are in a matrix form, so the runtime of each list in its elements, it's much more complex. So linked list is much more preferred due to its constant complexity. It does not change, and also it has a uh, linear complexity. That is all.